Hey guys, so I've just got my hand on the Methods 2022 Exam 2, and I'm going to be answering the questions. So, the question 1, the period of the function. Well, it's a cos function, so the period is 2 pi on n, and n is 2, meaning it should be pi, so B. Question 2, the graph of y equals 1 over x plus 3 squared plus 4. Horizontal asymptote meaning y equals. Okay, so this can never be equal to 0, meaning we're always going to add or subtract something to 4. So it can never actually be y equals to 4. So that's our asymptote. The gradient of the graph of y equals 3x at the point where the graph crosses the vertical axis is equal to. So the vertical axis, x equals to 0. So first we'll differentiate it, and dy dx is 3e to the 3x, and at x equals to 0, that's 1. So dy dx is equal to 3. Yep. Alright, which of the following functions is not continuous over the interval x is between 0 and 5? So this one has an asymptote at x equals to -3, but that's outside of that domain. This one also, from -3 to -infinity isn't defined, so that's outside as well. This never has an asymptote, it's always defined. This one, tan graph, has asymptotes, I'm assuming it would be that. Sine graph has no asymptotes, so it's always also defined. So I guess it's D. The largest value of a such that the function from -infinity to a is 1 to 1. So we want to stop at the turning point. So that's the maximum we can go to. So for in general form, the x coordinate of the turning point is -b over 2a. And so that would be -3 over 2, and a is 1, so -1.5. Which of the following pairs of functions below are not inverse functions? Okay, so x... So yeah, if we rearrange this, we'll get x minus 3 over 5, so not that one. 2x, so minus... x minus 2, yeah, so that's an inverse function. This one here is, we've got the x squared, but it's for less than 0. So if I were to draw, that would be like that. And then we took the positive square root, which looks like that. But actually, if we wanted the inverse function, we would need the negative square root so that it could be reflected in the line y equals to x. You see it like that and like that. So I think this one's the answer. Obviously 1 over x is the inverse of 1 over x, and log base e of x plus 1. Yeah, that's an inverse. Okay, so yeah, option C. The graph of y equals f of x is shown below. So we want the graph of the derivative. So we have a positive gradient here, so it's going to be looking like that, and it's going to stop here where we have a turning point. And then it becomes negative, so we'll keep going down. And then it goes to 0 here, and then positive again, so like that. Yeah, that looks like E. Okay, if 0 to b, the integral of f of x is equal to 10, and the integral from 0 to a of f of x is -4, we want the integral from a to b. So if we think about it like this, these are all, they've got a 0 in it. So if we want a to b, well, that's the same, and a is less than b, that means a is before b on the graph. That means if we have a to b, we could also say the integral from a to 0 plus 0 to b. So, a to 0 plus 0 to b. And we've got 0 to a. If we just change the bounds, then it changes the sign. So that's 4 plus, and then 0 to b is 10, so 14. Okay, the shortest distance d from the origin to the point x, y. So this point here is just x root 2x plus 1. So the distance is going to be the square root of x minus 0 all squared, so x squared, plus root 2x plus 1 minus 0 all squared, so that's just 2x plus 1. And the shortest distance, we differentiate and let it equal to 0. But why have they given the answers in terms of x? Because if we have shortest distance, then... yeah, if we have the shortest distance, then it will just be a value. Well, it's definitely not that, because it's the square root of that. It's not that. It's not that because we have a plus. If we factorize that, we get x plus 1 squared. And from 0 to infinity, we only take the positive. So it's just x plus 1. So even if you were to sketch that, you would find that that graph looks something like that and like that. And from 0 to infinity, the x plus 1 looks like, I'll just draw it in a different color. The x plus 1 is like that. And so from 0 to infinity, they're the same graph. So x plus 1 is the answer. I'm just not sure why they said shortest distance. That's really stupid. So when they say shortest distance, they mean that we don't go like that to that point, I'm guessing. But yeah, that's really stupid. I don't like the wording of that question. An organisation randomly surveyed 1,000 Australian adults and found that 55% of those surveyed were happy with their level of physical activity. So 95 confidence interval for the percentage of Australians who are happy with their level of physical activity. So looking at the answers, we only really need to check one side because they're all different. So if we get one side, then we've gotten the answer. So I'll just go to my CAS. Okay, so the confidence interval, we've got p hat minus, so p hat in this case is 0.55, minus, it's 95%, so 1.96, times the square root of p hat, which is again 0.55, times 1 minus p hat, over n, and n was 1,000. And that gives us 0.519. So in a percentage, that would be 51.9%. And so the answer would be D. Question 11. So this is a integration by recognition question. So I guess we'll forget about the 1 over k for now. If we want the integral of x over cos x, remember that the integral of this side is now equal to just without the derivative. And what that means is the integral, we can separate that right hand side into two integrals. That's equal to x sine x. And so if we just subtract it over, we get x sine x minus the integral of sine x dx. And so if we want 1 over k times that, we just multiply both sides by 1 over k. And I guess that one's obviously wrong then. We've got, no, we need to multiply by the whole thing, so that one's wrong. Yeah, and we've got C as the answer. Okay, a bag contains 3 red pens and X black pens. 2 pens are drawn randomly from the bag without replacement. The probability of drawing a pen of each color is equal to, so I think the best way to do this is a tree diagram. So we've got red, black, and then we're drawing two. So red, black, and then red, black. So for red at the start, we've got 3 red pens and X black pens. So we've got 3 over X plus 3. That's the total. And then for a red again, we're going to have, I guess we don't need the red because we only want 2 different colors, so there's no point working it out. For a blue after that, we've still got X because we didn't take any away from the X, but on that denominator, it's X minus 1 plus 3, so X plus 2. And for the blue, we have X over X plus 3. But then if we want a different color, red, we still haven't taken any away from that 3, so it's just 3, but it's over X plus 2. So if we want 2 different colors, we've got this times this, plus this times this, which is 3X plus 3X, so 6X over, yeah. Okay. The function f of x, where a is a positive real constant, has the maximal domain. So obviously we can't include a because, and so that makes a and e wrong, because if we sub that into the denominator, we get an undefined. And also that makes us reject this one here because we aren't excluding a in this here. We're including it. So that's wrong. So we're left between 2. Now, a is positive. So let's just sub in 0. And if we sub in 0, we want the inside to be greater than 0, because log base e of anything needs to be greater than 0. And if we sub in 0, we get a over negative a, so negative 1. And that's negative. So we can't have something in between negative a and a. We have to have everything else. So C is the answer. Continuous random variable x has the probability density function given by. So we just need to do the expected value, and that is the integral from negative infinity to infinity of x times fx. So I'll go back to my CAS. And if we just do, here we only need to do the integral from 0 to infinity because the rest is 0. So if we do the integral from 0 to infinity of 2 over 9 x squared, so remember multiplying the f of x by x, times e to the negative 1 over 9 x squared dx, and control enter, we get 2.6586 or 2.659, and so that makes the answer B. The maximal domain of the function with the rule f of x is given by, so this here we can just go on the CAS. I'm not sure if any of you know this, but the CAS can literally just find the domain for us. If you just type in domain, put in the function, minus 2x minus 3, just put a comma x, and it tells you it's from negative infinity to negative 1 or 3 to infinity. So that is, and negative 1 and 3 are included. So that tells me that the answer is E. Okay. The function f of x that has turning points at x equals to negative 3 and x equals to 1 and passes through the point. So we have 3 variables and we need to form 3 equations. So the first equation, well, we can have one for this, and also one for that. So if we say f of 3 equals to 4, that's our first equation because that's a point. Then we've got, let's just say g of x is f dash x. Then g of -3 is equal to 0 because the gradient equals to 0 at that point. And the same for that 1. So if we just put that on the CAS, it should give us the answer straight away. So it's menu 371 for the system of equations. We've got 3 equations and our variables are m, n, and p. So the first equation, I guess I'll define f of x first. As 1/3 x cubed plus m times, make sure you put that multiplication sign, x squared plus n times x plus p. Okay, and then I'll also define g of x as the derivative. Okay, and then we'll go back to that system of equations. So 3 equations, 3 variables, m, n, and p. And the first equation we had was f of 3 is equal to 4. Then we had g of -3 is equal to 0. And g of 1 is also equal to 0. And that gave us m equals 1, n equals -3, and p equals -5. And that is option B. Okay, the function g is continuous on the domain x is an element of a to b and has the following properties. So the average rate of change, so that means y2 minus y1 over x2 minus x1. So if we have a here, b here, that means it's positive, so it means we have to start lower and end higher for the average rate of change to be positive. But if this is a and that's b, then a plus b over 2 is in the middle. So the instantaneous rate of change, at that point, the gradient is negative. So we need to have something like that. And, well, that makes that wrong and that wrong. 1 to 1 is also wrong. Now, when we say many to 1, we mean many x to 1 y, and 1 to many is 1 x to 1 y, to many y. So the x always comes first. And if we just take a point here, a y value, there are many x values that give that same y value. So many x to 1 y. Okay, if x is a binomial random variable when n equals 20, p equals to 0.88. And we've got that there. We want to find a. So the given probability, the intersection. Now, well, there are 2 ways that you can figure out that a is less than 16. One, just look at all the answers. They're all less than 16. But also that if we have that a is greater than 16, then that means the numerator is going to be the intersection between 16, greater than 16 and greater than or equal to a, meaning it's going to be x is greater than or equal to a on the top, but also on the bottom it's greater than or equal to a, meaning that's just 1. So just looking at this question, we know that a has to be less than 16. And so on the top, we want the intersection is greater than or equal to 16. And on the denominator, we've got the greater than or equal to a. So I'll just go back to the CAS for that. And I guess this one is just probably the easiest to do as a trial and error. So on the top, we've got menu 5 for probability, 5 for distributions, and B for binomial CDF. The number of trials we had 20 trials, and we had P is 0.88. Our lower bound we wanted 16, and then the upper bound 20. And okay, and then on the denominator, I guess we can just copy and paste this down. But, oops. But just change that 16 to each answer option and see which one gives you that probability. So if we take a to be 11, we get 0.9173 and the answer was 0.9175, so probably not that one. Next one, 12. Yep, so 12 gives us that 0.9175. And that makes our answer B. So a box is formed from a rectangular sheet of cardboard with a length B. Oh, this is the typical question about cutting out corners. So this is X, that's also X. So I guess each side length is B minus 2X, and the width is A minus 2X. And then we also have a height for a volume of just X, because when we fold that part up, the height is just X. So this is, we just need to do an F max on the calculator for this. So I'll go back to the CAS once again. And we want F max of X times B minus 2X times A minus 2X, comma X. And we've got, what have I done? I guess we have to differentiate and let it equal to 0. So menu 3(1), the derivative of this equals to 0, comma X, and we get A plus B minus the square root, or A plus B plus. If we think about what graph we have, we've got a negative and we've got a negative and negative, which cancels to be a positive. So we have a positive cubic, which looks something like that, meaning the maximum is going to be before the minimum, meaning it's going to be we had the A plus B, and we had the A plus B plus the square root, and we had the A plus B minus the square root. And so it's going to be the A plus B minus the square root, so that we could get that before the minimum. A soccer player kicks a ball with an angle of elevation of theta degrees, where theta is a normally distributed random variable. Mean is 42. Standard deviation of 8. Horizontal distance that a ball travels. So now they're bringing distance into this. The probability that the ball travels more than 40 meters horizontally before landing is closest to. So we want that distance to be more than 40. So 50 sine 2 theta to be greater than 40. And I'm guessing you're not going to throw. So let's say you're here. You're throwing a ball like that. So you're throwing it anywhere between 0 and 90 degrees. You're not throwing it backwards. Actually, I guess you could throw it backwards and still get... Yeah, you could throw it backwards and still get that distance of 40 because distance. So I guess on your CAS, you're going to be solving 50 sine 2 theta is greater than 40 between 0 and 180. And make sure your CAS is in degrees. So we've got CAS in degrees, and then we want to solve 50 sine 2 times x to be greater than 40, comma x, and I guess we could say that x is between 0 and 180. Okay. We got the integers. Maybe if we just said 90. Still got integers. Okay, let's just do equal to. Okay, so we got these two values. And if you think about the sine graph, the maximum of this, the maximum is going to be 50. And that's going to be at pi over 2. So pi over 4 will give you the maximum, and pi over 4 is 45 degrees. So if you think about how this looks, you're going to get a sine graph where you've got 45 degrees is the maximum, and you've got 2663. So over is between there. So you want your theta to be greater than 26.565 and less than 63.4349. So we can do the normal solve on the CAS. So menu 552, the lower bound, I guess I should have written them down. I think it was 26.5. I forgot them. 63.43. Okay, so menu 552. Did I already forget them again? 63.43. My memory doesn't work. And we had the 26.56. The mean we had was 42. The standard deviation was 8. And we get 0.969. Yeah, and that looks like option A. So that is the multiple choice. Let's move on to section B. So the equation of the axis of symmetry. Oh, well, that's pretty easy. X equals to 0. The derivative with respect to x, I guess we don't even need the CAS for that. It's 2 times x over 12, or x over 6. The equation of the the gradient of negative 2 and the equation of the tangent to f at point M. So the M is where it has a gradient of negative 2, so f dash x, or x over 6, is equal to negative 2. So that's at x is negative 12. And at that point, what's the y value, or the f value? And that is negative 12 squared, so 144 over 12, which is 12. So y equals to 12. So we've got 2 points and we've got a gradient. So y minus y1, y minus 12 is equal to m, which was negative 2, x minus minus 12, so plus 12. Y is negative 2x, minus 24 plus 12 is minus 12. All right. The diagram below shows part of the graph of y equals f of x, the tangent to f at point M, and the line perpendicular to the tangent at point M. Find the equation of the line perpendicular to the tangent point passing through M. That's pretty easy to be done on the CAS. So we have, if we go to menu, calculus, normal line, and we do, the function we want is x squared over 12. Comma x, and we want that at negative 12. And that gives us x plus 2 over 18. And it's an equation, so you need to write y equals. The line perpendicular to the tangent at point M also cuts f at point N, as shown in the diagram above. Find the area enclosed by the curve. So we need to find the intersection point between that normal line and the x squared over 12. And we can just do that on the CAS. So menu 3.1, we've got this function here equals to that line there, comma x. We had that negative 12 that we obviously know about, but that 18 as well. We don't even need the y value because that 18 just tells us our bound. So the area is the integral from -12 to 18 of the top function, which is the straight line. So x over 2 plus 18 minus f of x dx. And that, we'll just work that out on the CAS. So shift plus for integral, -12 to 18 of this function here minus f of x dx, and we get 375. You can say units squared or whatever. Okay, another parabola is defined by the rule g of x equals to x squared over 4a squared. A tangent to g and the line perpendicular to the tangent at x equals to -b are shown below. Find the value of b in terms of a such that the shaded area is a minimum. So this is pretty much the exact same process as the other one, except we have a lot more variables now. So we want to find the equation of the normal at x equals to -b. And then we also want to find this intersection point. Well, obviously this one's -b, but the other one, so that we can, that tells us the bounds of our integral. So we'll do that on the CAS. And we've got, we want the same function that we used above, so we'll just go normal line, but this time it's x squared over 4a squared. And we want it comma x and comma -b. And so that's our normal line. I'll just write that one down. And then we want the intersection. So menu 3(1), we want the intersection between this line here and that function, comma x. We get that -b that we knew about and that 8a whatever. Plus b squared over b, and then that -b. So our area is the integral from -b to that massive thing of the top function, which was this. This is a bit annoying to write out. And then minus the x squared over 4a squared dx. And we want the value of b. So we want a minimum, so we're going to differentiate it. But this here is, this area is nothing in terms of x, so we're not differentiating with respect to x, because when we integrate and sub in the bounds replace x, so we've only got something in terms of a and b. So if we're differentiating and let it equal to 0, we should, finding b in terms of a, so just think like, that's like saying find y in terms of x, then we're going to probably differentiate with respect to a, just like we would differentiate with respect to x. So on the CAS, we've got -b to this thing here of that function that we found before minus this one here. And then we want to menu 3(1) and solve the derivative with respect to A of this equals to 0, and we want for B in terms of A, so comma B, and that gives us B equals to negative 2a squared root 5, or B equals to 2a squared root 5. Okay, now B is positive. Yep, B is greater than 0, meaning we reject that, and that is our answer. Okay, this looks a bit annoying. There are only 2 species of animals, foxes and rabbits. The foxes are the predators and rabbits are their prey. Population of foxes and rabbits increase and decrease in a periodic pattern. The period of both populations is the same. And T is measured in weeks, 1 point of minimum fox per whatever. Okay. The initial population of rabbits, so that's just when T is 0. So that's just 2,500. Minimum and maximum. Okay, well, the minimum is just going to be 2,500 plus the 1,700, and that's 4,200. And the minimum is going to be 2,500 minus the 1,700, and that is 800. Okay. The number of weeks between maximum population of rabbits, well, you could just get that from the graph, or you could just work with the period. It's 160, looks like it. We'll just check with the period. Yeah, so the period is 2 pi on n. So 2 pi divided by pi over 180 is 2 times 180, which is 160. All right, the population of foxes can be modeled by the rule f of t equals to a sine bt minus 60 plus 1600. Show that a equals to 900 and b equals to pi over 80. Oh, so we've got 2 points, the minimum and the maximum. But we've also got, they said the period of both populations is the same. So the period is the same. So period of foxes equals period of rabbits, and that's equal to 160. So that means 2 pi over b is equal to 160, meaning b is 2 pi over 160, which is pi over 80. And that's what we wanted to show for b. And that makes f of t equal to a sine pi over 80, t minus 60. And then we're just going to use a point. So we'll use the 100, 2,500. So f of 100 equals to 2,500. Oh, sorry, I forgot a plus 1,600 here. So 2,500 is equal to a sine pi over 80 times 40 is pi over 2. So sine pi over 2, which is 1 plus 1,600. So that means a is 2,500 minus 1,600, which is equal to 900, as we want. Okay. Find the maximum combined population of foxes and rabbits. Give your answer correct to the nearest whole number. So the maximum combined, we just need to add the 2 functions. So we'll do that on the CAD. So we'll just define h of t as this one here, which was 900 sine. I'll go back to radians, make sure you did, hope you did that on the exam. Sine pi over 80 And then we've got t minus 60 plus 1600. And then we also want to add the rabbit one, which was 1700 sine pi t over 80 plus 2500. Okay, and we want, what do we want? We want the maximum combined. So we want to do a menu 3 1, or we could just do a shift, an F max of h of t, comma t, and it's a sine graph, so we're probably going to need to put a domain. We'll just put, the period is 160, so the maximum should be somewhere in between. And to the nearest whole number, so we can get it as a decimal. So that occurs at t equals to 53.7. So what's h of that? Gives us 5339 rabbits. What is the number of weeks between the periods when the combined population of foxes and rabbits is a maximum? Well, I'm just guessing. Obviously that it will just repeat again to be 160. We'll just check that. Now let's do 2 periods on the CAS, so 320. And we get what? 213, and what's h of that? The same, and that is plus 160. Yeah, so 160 weeks again. Okay, the population of foxes is better modeled by the transformation of y equals sine t. So that's the population of foxes. The average population during the first 300 weeks for the combined population of foxes and rabbits is sine t under the trend. Okay, so first we want to find the new graph of y. So if we just look at that, t dash is 90 over pi t plus 60. That makes t equal to pi times t dash minus 60 over 90. Then if you look at y dash is 900 y plus 1600. That makes y equal to y dash minus 1600 over 900. Okay, so now instead of y we have y dash minus 1600 over 900. That's equal to sine of t, but instead of t we have pi t dash minus 60 over 90. And now I guess we can get rid of the dashes, so it's just y is equal to 900 sine pi t minus 60 over 90 plus 1600. Okay, and then that's for the foxes. Find the average population for the combined foxes and rabbits. So the average value is 1 over 300. We have 0 to 300, but we want the combined. So this is the foxes. Plus the rabbit one, which was 1700 pi t over 80 plus 500 dt, and that equals to the nearest whole number. So we want shift plus, no. And we've also got 1 over 300 on the outside. 0, 300. Then we've got 900 sine pi t minus 60 over 90 plus 1600. And then plus, and surely I've used that somewhere else. Yeah, here, I'll just copy that one down. dt, oops. And that will give us 4142. Okay. Next question. Oh, this question's still going. Alright. Over a long period of time, it is found that the increase and decrease in the population of rabbits gets smaller and smaller. Population of rabbits over a long period of time can be modeled by the rule. That rule. The average rate of change between the first 2 times in the population is at a maximum. So, I guess the first 2 times we have a maximum would be, if we solve, s dash t equals to 0. T is an element of 0 to 320, so 2 periods will give us 2 maximums. So we'll do that on the CAS. First, I'll actually define the function so it can make my life easier. So s of t, oops. I'll do it in x just in case I want to graph anything. Define that as 1700 e to the negative 0.003 x times sine of pi x over 80 plus 2500. And we want to solve the derivative equals to 0, or we'll just do on the CAS f max of s of x, comma x, and we will say from 0 to 320. And that gives us only one value. Or maybe we'll just do till 480 for a third period. Only one. Because that's the highest. Okay, so I guess we need to do them separately. So 0 to 1, because it's multiplied by an exponential, we've got a maximum in the first period, but then another maximum in the second, but it's just not as high as the first one. So it just takes that the 38 is the highest. So our first one is 38.058. And our y value, or our s value, is 4012. .167. And then we've also, if we just do 160 to 320, we should get another one. Yeah, so 198.058, and s of that gives us 3435.704. Okay, so the average rate of change is going to be the 4012.167 minus 3435.704 over 38.058 minus 198.058. And that's just the 160, that's just the period, a negative 160. So, if we do that on the CAS, got that minus that over negative 160. And that should give us negative 3.60 to one decimal place, negative 3.6. You could say rabbits per what time? T is in weeks, per week. But I guess it doesn't really matter. Find the time where T is greater than 40 in weeks, when the rate of change of the rabbit population is at its greatest positive value. The rate of change is at its greatest positive value. So we want to solve the double derivative is equal to 0, or the maximum double derivative. So we could do that. So menu 3, 1, and we have the derivative of the derivative, so I guess the double derivative of s of x equals to 0, comma x, and say x is greater than 40. What do we have here? We've got... Okay, well, if we were to sub in... So these n's just mean integers. If we were to just have 1 here, that first one wouldn't be right because we're going to have a negative value of x times 80. So we can't have that. Or, do we have another one? No, just that. So, let's say we took took 1 as our first integer. What is that? I think that's... So if we try s of that, but we try 1. Oh, sorry. We're subbing that into the derivative. We want the derivative to see the greatest positive value of the derivative. But we want this to just be 1. Let's see what we get. We get a negative. So now let's try 2. We get a positive. Now let's just try 3 to see if we get lower and lower. We got a negative. We got a smaller negative, so we're getting closer and closer to 0. Yeah, so that positive is not as great as that positive. So the greatest one is for that first value of 2. So you could solve s on the CAS. S double dash of t equals to 0. T equals to, you could write that 80 minus 0.049. And n is an element of integers. And then you could say greatest positive occurs for n equals to 2. And you want the time, so t is equal to (156) to the nearest whole number weeks. Over time, the rabbit population approaches a particular value. State this value. Well, as t goes to infinity, that goes to e to the negative infinity, and that's 0. So this whole thing becomes 0, and you get 2,500. Finally, this question is done. Mika is flipping a coin. The unbiased coin has a probability of half landing on heads and half landing on tails. Let x be the binomial random variable representing the number of times that the coin lands on heads. Mika flips the coin 5 times. Find probability that x equals 5. So we've got x is a binomial, flips it 5 times, and the probability of success is a half. So we've got 5c5, which is 1, then 1/2 to the power of 5, and then 1/2 to the power of 0. So 1, 2, 4, 8, 6, 32. 1 over 32. Probability that x is greater than or equal to 2. I'm just going to use the CAS. So menu 55B. Number of trials was 5. Our probability of success was 0.5. Lower bound is 2, and we want the upper bound of 5. We get 0.8125, but they probably want it as a fraction. So menu number 13 over 16. And then find probability x is greater than or equal to 2 and x is less than 5, correct to 3 decimal places. So the given probability is probability that 2 is less than or equal to x, which is less than 5, over probability that x is less than 5. This is a discrete random variable, so that's the same as that, and the denominator is the same as that. What does that give us? Let's go on the CAS. Fraction. We've got on the numerator, menu 55B, we've got 5 trials again, 0.5 again. Our lower bound was 2, our upper bound is 4. And on the denominator, we've got 5 trials, 0.5, but instead we're going from 0 to 4. And that gives us 0.806 to 3 decimal places. Let me just check that. 2 to 4 on the top. Yeah, and 0 to 4. Okay. Expected value and standard deviation. Well, that's not too bad. If we have x is binomially distributed 5 and 1/2, the expected value is 5 times a half, so 5 over 2. And our standard deviation is the square root of np times 1 minus p, so 5 over 2 times 1 minus p, which is 1/2. And that is root 5 over root 4, which is 2. Alright. The height reached by each of Mika's coin flips is given by a continuous random variable h with a probability density function. F of h is that. H is vertical height reached by the coin flip between the coin and the floor. A, B, C are real constants. The value of the definite integral 1.5 to 3. It's probability density function, meaning the whole probability has to be 1. Okay, given that probability h is less than or equal to 2 is that, probability that h is greater than or equal to 2.5 is that. Find the values of a, b, and c. So we have 3 variables, we need 3 equations. The first one could be the integral from 1.5 to 2 of f of h dh. That's 0.35 as we're told. Next one, 2.5 to 3 of f of h dh is 0.25. And our last equation could just be the one we had in the part bi. So 1.5 to 3 of f of h dh is equal to 1. So if we just solve that on the CAS, we should get all the answers. Okay, so I'm just going to define f of h as... Do I have h defined as something? Yep. Menu 1, 3 to delete that. Okay, so menu... no, I need to define first. Define that as a times h squared plus b times h plus c. Okay, and then we've got menu 3, 7, 1. We've got 3 equations. We've got A, B, and C are our unknowns. First equation, integral from 1.5. I don't need Siri. To 2 of f of h dh is equal to 0.35. And then just copy that down, change the numbers. So we had 2.5 to 3 is 0.25. And then paste it again. And that was 1.5 to 3. Okay, so we get A is negative 4/5, B is 17 over 5, and C is negative 167 over 60. Alright, that's not too bad of a question. The ceiling of Mika's room is 3 meters above the floor. The minimum distance between the coin and the ceiling is a continuous random variable d with probability density function g. The function g is a transformation of the function f given by g of d is f of rd plus s. D is the minimum distance between the coin and the ceiling. R and s are real constants. Find the values of r and s. So, the original was from the coin on the floor. So the height from the floor to the coin, but G is the ceiling to the coin. So if we have like floor, ceiling, coin is like here. That's our height from the floor to the ceiling. This whole thing is 3 meters. So from the ceiling to the floor, it's just going to be f of 3 minus d to get that one here. And so I guess, well, that's the same as negative d plus 3. And I guess that gives us the answer. So r is negative 1. S is, oops, not negative 3, negative 1. And S is 3. Okay. Mika's sister, Bella, also has a coin. On each flip, Bella's coin, of course she does. On each flip, Bella's coin has a probability P of landing on heads and 1 minus P of landing on tails, where P is a constant value between 0 and 1. She flips it 25 times in order to estimate P. Let P hat be the random variable representing the proportion of times that Bella's coin lands on heads in her sample. Is the random variable P discrete or continuous? Of course it's discrete. Justify your answer. Well, the number of times she, you could say, yeah, number of times she flips the coin is positive integer values, because you can only flip it 1, 0, 1, 2, 3, 4, 5, and so on, including 0 as well, because you can flip it 0 times. Meaning P hat can only take discrete values. If P hat is 0.4, find an approximate confidence, 95% confidence interval, correct to 3 decimal places. That's 0.4 minus 1.96 square root 0.4 times 0.6 over 25, and then the exact same. And we'll see what the CAS gives us for that. So, left side we've got 0.4 minus 1.96 times the square root of 0.4 times 0.6 over 25. And that gives us 0.208 to 3 decimal places for the left side. And if we just enter that down and put a plus there, that gives us 0.592. Okay. Bella knows that she can decrease the width of a 95% confidence interval by using a larger sample of coin flips. If p hat is 0.4, how many coin flips? Well, so the width of the confidence interval is the margin of error, or half of it. So we want to half our margin of error. Now, margin of error is directly proportional to that thing, p hat minus over n. So if you just think about it, that's margin of error is directly proportional to 1 over the square root of n. Meaning if we want to halve the margin of error, what we have to do is multiply that by the square of 2. So multiply n by 4. And if n was 25, that means we want 100 here. The range of f of x, well, that's just r, f dash of 0. Okay, well, f dash of x is 1 over x plus 1/2 minus, so plus 1 over negative x plus 1/2. And f dash of 0 is 1 over 1/2, so 2 plus 1 over 1/2, which is 2. So 2 plus 2 is 4. The maximal domain over which f is strictly increasing. It's always increasing. So for the domain that it's defined. Show that f of x plus f of negative x equals to 0. Okay, well, ln of x plus 1/2 minus ln negative x plus 1/2 plus ln negative x plus 1/2, so we replace x with negative x in the next one, minus ln of negative x, so x plus 1/2. And that cancel, that and that cancel, which equals to 0. The domain and rule of f inverse, the inverse of x. We can just do that one. We'll do that one by hand. Or we can do it. No, it's 3 marks. We'll do it by hand. So, f of x, I'll just write it down so I don't have to keep scrolling up. We can combine that into 1. So that's ln x plus 1/2 over negative x plus 1/2. And the inverse, swap x and y. So x is equal to ln y plus 1/2 over negative y plus 1/2. Meaning e to the x, or y plus 1/2 over negative y plus 1/2 equals e to the x. Now, if we multiply that over, y plus 1/2 equals to e to the x, negative y plus 1/2, or negative e to the xy plus e to the x over 2 If we just move this over to the other side, we can take out y as a common factor. We get e to the x plus 1, and then equals to e to the x plus 1 over 2, minus 1, because we moved the 1/2 over. And then that makes y equal to e to the x minus 1 over 2 e to the x plus 1. And instead of y, we should write f inverse. And we want the domain of the inverse, that's just the range of the original, which was R. So that's that. Let h be the function that 1 over k log base e of whatever. So it's the same function, but just dilated by a factor of 1 over k from the x-axis. Now, k is an element of real, k is greater than 0. Why didn't they just say k is an element of real positive? The inverse function of h is defined by the inverse. So they actually gave you the answer to this question here. So if you just sub in k is 1, then you get e to the x minus 1 over 2 e to the x plus 1. Oh, I guess so, we wrote the right answer. Well, yeah, so if you struggled on that question before, hopefully you noticed that they actually gave you the answer. And just copied it down. The area of the regions bound by the functions h and h inverse can be expressed as a function a of k. The graph below shows the relevant area shaded. You are not required to find or define a k. Determine the range of values of k such that a of k is greater than 0. So if a of k is greater than 0, that means we have a bounded area. So if we just draw a line y equals x, if we don't have a bounded area, that means this h is like that, and that makes h inverse below the line y equals to x, and we don't have a bounded area. And the same for the negative parts. So we want to find, because the point where that starts happening, where h becomes above the line y equals x and h inverse becomes below the line y equals x, well, they start by just touching the line y equals x, like that. And then when we want all the values of k such that this goes up even more and this goes down even more, and we want to reject those values. So at this point, we know that h of x equals to x, and also the gradient at that point, the tangent at that point, is the same as the gradient of the line y equals x. So h dash x equals to the gradient of the line y equals x. So we can solve that simultaneous equation and see what point that starts happening. So on the CAS, menu 371, we've got, x and k are our two variables. Actually, I'll define h of x first. H of x, we'll define that as 1 over k times ln of x plus 1/2 minus ln negative x plus 1/2. Okay, so now we can do what we wanted to do, menu 371. Well, our two variables are x and k. Our first equation was that h of x intersects the line y equals x, but our second equation was that they have the same gradient. And of course, the CAS does not want to solve that for me. Maybe we can get it as a decimal and see what we're about. Oh, it's 4. So at k equals 4, what's happening is that the inverse and the original, h of x and h inverse, are just touching. And that's also when we don't have a bounded area. But let's just see if we sketch h of x. Yeah, we'll create a slider. Just put 4, and we'll sketch the inverse. So how you can do that is menu, graph entry, relation, x equals to f of y. Not f, sorry, h. Did I sketch? Yeah. So, yeah, you can see from 0, 0 obviously is undefined because 1 over 0. 1, 2, 3, 4. That's when they touch. And then after 4, I'll even put more. So if you do control menu, you can edit your slider. So value, we'll say we want to check like 10, let's say 10. And yeah, you can see we've got that intersection. So from 4 onwards, we have that bounded area. So for k is greater than 4. Okay, explain why the domain of A of k does not include all values of k. Well, because firstly, k can't be 0 because then we have undefined. But also because there's not all values of k give a bounded area. So A of k won't exist for all values of k. Okay? Alright. I think that's probably the toughest question. This one here especially. So far. It hasn't been too bad. This is the last question. Oh, we made it. Okay. Oh, that's weird. They never give functional equations questions. Consider the composite function g of x equals f of sine 2x, where the function f of x is an unknown but differentiable function for all values of x. So this tells us about f of x and f dash of x. Find the value of g of pi over 6. G of pi over 6 is f of sine of pi over 6. Sine of 2 times pi over 6, which is pi over 3, which is f of root 3 over 2. And surely they gave that to us there, which is 3. Yeah, okay. The derivative of g with respect to x is given by that, so it's annoying that they've actually done it for you, so they haven't made it too hard. Because you could have done that just by using the chain rule. Show that g dash pi over 6 equals to 1/9. Okay, well, g dash pi over 6 is equal to 2 because 2 times pi over 6, or pi over 3, times f dash of sine of pi over 3. We also found, okay, so that is 2 cos 2 times 1/2, and then, which is just 1, and f dash of sine pi over 3 is f dash of root 3 over 2. So, and f dash of root 3 over 2 is 1/9, as we wanted. The equation of the tangent to g at x equals to pi over 6. So we know that the gradient is 1/9. And we know that the point, or g of pi over 6, which was the first part, is 3. So y minus y1, y minus 3 is equal to m, 1/9, x minus x1. So y is 1/9 x minus pi over 54 plus 3. think. Is that right? 1 x minus pi over 54 plus 3, yeah. The tangent to g, so g of pi over 6 is 3. Yeah, that looks about right. The average value of the derivative function g dash x between x equals to pi over 8 and x equals to pi over 6. So the average value is 1 over pi over 6 minus pi over 8 times the integral from pi over 6 to pi over 8 of g dash x dx. Now, pi over 6 minus pi over 8 is 8 pi minus 6 pi. Actually, we could do 4 pi minus 3 pi, so pi over 24. So 24 over pi, I think. 4 minus 3 is 1 over 24. Yeah. And then we've got g of x, because that's the integral of g dash x, from pi over 6 to pi over 8, and that's 24 over pi. Now when we sub in g of pi over 8, what do we get? That's sine of pi over 4, which is root 2 over 2, so f of root 2 over 2 is 5, minus pi over 6, we already found that, which was 3. Sorry, I made a mistake. It's pi over 8 to pi over 6. And that makes this the other way around. So 3 minus 5, which is negative 48 over pi. Okay. Last question. Usually last questions are really hard. Let's see how they are. 4 solutions to the equation g dash x equals to 0 for the interval 0 to pi. So g dash x equals to 0. They told us g dash x was, so 2 cos 2x, and then f dash sine 2x equals to 0. So with the null factor law, this can be 0 or that can be 0. So let's take the first case. 2 cos 2x equals to 0. Well, that's the same as cos 2x equals to 0. Also, x is between 0 to pi. That makes 2x between 0 and 2 pi. So we're looking for values between 0 and 2 pi. So 2x is equal to, cos is equal to 0 at pi over 2 and 3 pi over 2. So that makes the first case give us 2 solutions only, which are pi over 4 and 3 pi over 4. Now the second case is if f dash equals to 0. F dash equals to 0 for root 2 over 2. So we want root 2 over 2 in here, because f dash of root 2 over 2 equals to 0. So sine 2x equals to root 2 over 2. Now we said it's between 0 and 2 pi. So 2x is equal to, we've got pi over 4, and the next one would be 3 pi over 4, making x pi over 8 and 3 pi over 8. Those are 4. So x was pi over 4, 3 pi over 4, pi over 8, 3 pi over 8. And those are the 4 solutions. So that takes us to the end of the methods exam for this year. I don't think that was very, it wasn't the easiest question, but it wasn't necessarily a typical last question of VCA, because this pretty much involved no CAS at all. I think they could have asked this as a last question on exam 1. And it still would have been fine. This whole question, actually, I don't think I used the CAS at all for this question, and I don't think you needed to. So, not sure why it was on exam 2. But that's alright. I think it was a pretty doable exam. It was pretty fair, maybe a little bit long, but I think still it was all okay. Yeah, but thank you for watching.